Good day, students. I hope I find you well. Welcome to yet another exciting edition of Chemistry World Lessons. Today, I am into the world of organic chemistry. I'm just going to look at some of the classes of organic compounds that we normally encounter at our IGC, SC level or O level. All right. So we're just going to discuss the characterization of such compounds, the general formulae, and how we can distinguish them. Normally in your exams, you are given the structural formulae, the displayed formulae, and they ask you to identify them or even to fish out a compound which will not be belonging to the rest, okay? So today's session is basically to help you to identify the functional group of each of these organic compounds and also how we can write down the general formula for each class, okay? So on the board, I have a topic classes of organic compounds. Right, so you're going to find out that this is another way of writing your notes, okay? You can actually put organic compounds in the center and then you put arrows to indicate the classes, okay? So I have organic compounds, I have alkanes on this side, I have alkenes on that side, okay? At the top I have alcohols and at the bottom I have carboxylic acids, okay? So in order to study chemistry, we normally group compounds, okay? Put them into families. Those that behave the same, those that have the same functional group, they will show similar chemical reactions, and as a result, they are said to be belonging to the same homologous group, okay? Now, let's start with alkane family, okay? I want you to notice something about the alkane family, okay? The suffix here is -ane, okay? Right? That's like their synonym, all right? And here, the suffix is -ine, all right? So all compounds that are found in the alkane group are going to have, they're going to end their name with -ane, okay? Right, so in a moment I'm just going to rub and then I'll deal with each group separately. So you're going to find out that all the compounds here are going to end with -ane, here, -ine. But for alcohols, these are rather special, okay? Alcohol, so all their names are going to end with -ol, okay? Carboxylic acid, also special, all their names are going to end with -oic, okay? So I want you to take note of what I've just mentioned here so that we'll be in a position to realize the name and the naming system of our organic compounds, okay? But just to preview, I can say if a compound is written as propane, okay, you underline the word -ane. It belongs to the alkane group. But if a compound is written as propene, okay, it's -ine, so it belongs to the alkene group. But if a compound is written as propanol, okay, now the -ol is actually rhyming with alcohol. It's -ol, so it's an alcohol. Propanol is an alcohol. But if someone says propanoic acid, okay, propanoic acid, the oic signifies it's a carboxylic acid. So I can have propane, propene, propanol, propanoic acid. These are signifying different functional groups present and also different classes of compounds. So alkanes, alkenes, alcohols, carboxylic acid, these are the classes that we are going to discuss today, okay? Let's start with alkanes, okay? Alkanes, right? Alkanes, these are hydrocarbons, okay? Alkanes and alkenes, these are hydrocarbons. So I'm going to deal with alkanes and alkenes, and then we have a comparative approach, okay? Alkanes and alkenes, these ones are hydrocarbons because the compounds consist of hydrogen and carbon only, okay? So it's very important for you to appreciate the fact that alkanes and alkenes, the similarity is the fact that both are hydrocarbons, okay? Right, so these ones have single bonds, okay? The alkanes have single bond, all right? And carbon in organic chemistry shows a valence of 4, meaning to say as you draw your molecules, you have to ensure that each and every carbon atom has 4 bonds around it, okay? So the first bond, okay, the prefix in organic chemistry if it's one carbon, we use meth, okay? Meth, because then alkane is going to be called methane, all right? So this is the formula, the displayed formula of methane, and if you count here, you're going to have CH4, okay? CH4, that's the first bond with only one carbon atom, okay? If we go further, we have two carbons. So we are going to have 1, 2. Each carbon must have how many bonds around it? 4. Okay, so the second bond is going to be like that. Okay, 1, 2 carbons, C2H6. Okay, right? And in organic chemistry, if there are 2 carbons, we move from meth to F. Okay, this is systematic and you have to learn this. So this one is called ethane. Okay, ethane. Now, if you add the third one, you have 1, 2, 3, each carbon, 4 bonds around it. These are hydrocarbons, only carbon and hydrogen present. Okay, so you're going to have that. Okay, right? 1, 2, 3 carbons, C3, and you count the H, 1, 2, 3, 4, 5, 6, 7, 8. So C3H8. Okay, so the third one, okay, in organic chemistry, we use the prefix prop, and the name is propane. So we have methane, propane, ethane. We could expand, okay, putting more carbon atoms here. Now, I want you to relate what is happening here in as far as the number of hydrogen and the number of carbons are related, okay? Now, we want to check carefully what is happening. If I have 1 carbon, I'm going to have 4 hydrogens. If I have 2, I have 6. If I have 3, I have 8, okay? So we can actually investigate a very simple mathematical relationship to relate these two numbers, okay? If I have 2, I have 6, okay? Meaning to say, what has happened here? For me to move from 2 to 6, for me to move from 1 to 4, all right? It appears as if that if I take this number, okay, and I multiply it by 2, and I add a 2, I will always get the number for hydrogens, okay? What am I saying? If I have 1 carbon, and then, okay, I multiply by 2, I'll get 2. If I add, okay, 2, I'll get 4, okay? The same applies here. I have 2. If I multiply by 2 and I add a 2, I'll get a 6. So that's the relationship between the number of carbon and hydrogen. The number of carbon and hydrogen. You can also do the same here. 3 times 2, 3 times 2 plus 2, you get 8. So that is the relationship between the number of carbon and the number of hydrogen. So a person could ask you, what is the general formula for alkanes? Okay? If I have any number of carbon atoms, I would say, okay, if I have any number of carbon atoms, let me call it N. How many hydrogens am I going to have? I have to take my N and I multiply it by 2 and I add a 2. Okay? This will be the general formula for my my alkane. Okay? The C must be multiplied by S, and then the hydrogen you multiply by 2 and you add a 2. Okay? Right? Even if I'm given a hydrocarbon, for instance, in alkane with 20, okay, carbons. So if it's C20, okay, I have to say 20 times 2 plus 2. It will become C2H42. So whenever I analyze a hydrocarbon and I notice that the relationship is times 2 plus 2, that hydrocarbon is an alkane. Okay? And all our alkanes, as you can see, they have single bonds. Okay? And you see carbon is carrying the maximum bonds around it. Okay? If you want this to react, you have to carry out substitution. So this group of compounds are saturated. Okay? They are generally unreactive. Okay? due to the fact that carbon is carrying the maximum number of bonds around it, okay? And as a result, if you want methane, ethane, propane to react, okay, you have to carry out substitution. Just like you can have a team of football, and then they are 11 players, football or soccer, whatever you call it, okay, 11 players. That team is now saturated. If you want to introduce another player, you have to substitute. So if you want to introduce another atom there, you have to get rid of hydrogen first, and you introduce the incoming atom. Okay, enough about alkanes. Let's move to alkenes, right? These ones have double bonds, okay? These have double bonds. The fact that I've already put a double bond there, it means at least there should be a double bond. So in alkenes, we don't start on carbon number 1. We start on carbon number 2. Because alkenes, at least there should be a double bond between 2 carbon atoms. So as a result, we cannot have an alkene with only 1 carbon. So we start on number 2. Each carbon, 4 bonds around it. Okay? 1, 2, 3, 4. Okay? And we also have 1, 2, 3, 4, like that. Okay? And 2 carbons, we said is like here. Is, and because it's an alkene, it's going to be ethene. Number 3. Okay? At least we should have a double bond. So we start from there. Now I want to show you something here, which students normally make a mistake. Okay? This middle carbon, all right? It has 1, 2, 3 bonds. You cannot put hydrogen down here and another hydrogen there. I'll show you and then I'll rub it. If you do that, okay, this is not correct because carbon now has 1, 2, 3, 4, 5 bonds. Okay? So it means the middle carbon must only have 1 hydrogen. Okay? Let's just go to carbon number 4. At least a double bond should be there. Okay? And then I put my carbon atoms. 1, 2, 3, 4. Okay? These ones, okay? You have a bond there. Okay? A bond here, a bond there. Be careful again here. You are going to have only 1 hydrogen. Okay? Right. So, let's analyze and do it the way we're doing there. Okay? If you look at the formula, okay, 1, 2 carbons, so it's C2H4. 1, 2, 3, let's count the hydrogens. 1, 2, 3, 4, 5, 6. So it's C3H6. Here, let's count the carbon. 1, 2, 3, 4. C4. 1, 2, 3, 4, 5, 6, 7, 8. Okay? C4H8. As we're doing here, what should I do if I have a number here in order to get the hydrogen? This one is fairly straightforward. Okay? If I have a number here, I simply multiply it by 2. 2 times 2, 4. 3 times 2, 6. 4 times 2, 8. Okay? So, the general formula now, let me just remove this and write it down here. C2H4. So, the general formula will be such a way that if I have any number of carbon atoms, if I multiply that number of carbon atoms by 2, I will get my number of hydrogens. So, you've actually seen that for alkanes and alkenes, they have a general formula, or they have general formulae. The only difference is for alkanes is CnH2n plus 2. For alkenes, it will be CnH2n. Okay, these two are called hydrocarbon because you only have carbon and hydrogen. If you get a question which says define the term hydrocarbon, you say this is a compound that has carbon and hydrogen atoms only, okay, in the molecule. That is the answer for that question. Okay, right? That's time for reflection. Quick reflection before we end. Today, I'll just focus on hydrocarbons, and in my next session, I will then move on to alcohols and acids. Okay, we'll be doing the same comparative approach. Just quick reflection. So, if I have C20, H42, C20, H40, C18, H38, okay, C18, H36, okay, let's make it shorter, C9, H18, and then C9, H20, okay. I could ask you for these 6 hydrocarbons, okay, classify them as alkanes and as alkene. So I need to just put the general formula beside each, and after that I'll be in a position to say that one is an alkane, this one is an alkene, okay. If you look at this one, 20 by 2 is 40, so this one is CN H2N. This one is also CN H2N, 18 by 2, right? This one is 9 by 2, 18 plus 2, 20. So this one is CN H2N plus 2. This one, CN H2N. And that one, 18 by 2, 36 plus 2, 38. So this one is CN H2N plus 2. This one, 20 by 2, 40 plus 2, 42. So it's CN H2N plus 2. Once you have done that, you have managed to distinguish which ones are hydrocarbons called alkenes and which ones are hydrocarbons known as alkanes. In this way, using the general formulae, you will be in a position to classify your organic compounds. So in my next session, I am going to look at alcohols and carboxylic acids. I'm going to use the same approach, comparative approach, and then we'll be in a position to look at how we can distinguish between them. And then when we are done, we then move on to their chemical reactions. What can we do in the lab to tell that this is an alkene and that one is an alkane? Right. Thank you for listening to this session. As I always say, if you are enjoying the sessions that I'm delivering to you, like, subscribe, share with your friends so that they'll also benefit. Otherwise, it's enough for today. I hope you've managed to learn a bit of mathematical approach in organic chemistry. It's bye-bye for now.